Hi children, how are you all? Hope you are all sincerely revising all the subjects for your periodic assessment too. I welcome you to math session, and today we are going to revise Introduction to Graph chapter. Okay, earlier on Monday we revised cubes and cube roots. It's a easy chapter, so we revised it on Monday. After a long gap, 3 days, we are again getting into math session. And this will help you a continuous revision for your exam. Okay, this introduction to graphs chapter was taught long before, and you would have forgotten many things. So I thought let it revise when it is closer to exam. So I chose this chapter. This is the right time to revise now. Okay, before getting into the revision, let's have a thought about books. Books or mirrors? Books or mirrors? Mirror shows us what we are, how we look, how about our physical features. These books will tell us what we already have inside us. That's how it's stated here. Books or mirrors, you only see in them what you already have inside you. Each and every one of us go and choose a book depending upon what is inside us. Okay, some may go in for adventurous book. Some may go in for cartoon comics. Some may go in for family stories. Isn't it? Some may go in for biographies. Some may be just a light touch up here and there. Not interested much in reading. But don't avoid books, children. Be close to books. Try to read as many books as possible. Whichever you are interested, you can read that book. It is not compulsory you should read only this kind of books, that kind of books. No restriction over any kind of books. You have to read as many books as you want. You choose your own taste. Okay, children? Okay. And let it be a relaxation for you during this revision time. Instead of sitting in front of a laptop or playing something, you can go in for reading books. Okay. And now today we are going to revise Introduction to Graphs. To start with, you already know bar graphs. Then double bar graphs and pie charts. I am not going to revise much about all these three things because it comes under the chapter data handling. But then as we have graphs, you are supposed to do, you should know to interpret all these graphs. You may get questions in interpreting any kind of graphs, okay, including pie chart. Though I may not ask you to calculate any angles or such things, but interpretation of pie chart may be there. Okay. Then the thing is histogram. The very special thing about histogram is it is about representation of continuous data. Okay. See, it should be very continuous. From 0 to 2, 2 to 4, all these widths should be equal. From 0 to 2, see here 1, 2, 3, 4 bars are there. Similarly, from 2 to 4 also you will have 4 bars. 1, 2, 3, 4. These are the basic things that a histogram should have. The intervals, the width of the intervals, that class intervals will represent the width of the bars. Here 4 bars are there. 4 bars together will have one single measurement and it will be kept over throughout that histogram. See here, even though there is nothing in the time period between 10 and 12, in between, no, like 11 or 10.5 and something like that, they have left some space over that. Okay, children? The class interval, this 0 to 2, 2 to 4, 4 to 6, 6 to 8, it is continuous. You should note down this thing especially in histogram. That's the speciality of histogram. And this class interval is equal to width of the bars. We have bars, no? Width of the bars. The height of the bars gives the frequency. This is the height of the bar. This height will gives us the frequency. Height gives us the frequency. Width of the bar gives us the class interval. Okay, children? Then two of your friends had doubt in this question which I asked in last test, periodic assessment 1. See, the following data shows prices of meals at Bob's Burgers. Price of meal options at these are they have listed on few options, few prices. Which histogram correctly displays the information above? Before looking at this information, no, how many 6 are there, how many 7, how many 9s are there, before counting that, I first look out the graph, which one satisfies the basic rule of histogram, which one does not satisfies the basic rule of histogram. When I come to the last thing, no, here it is hidden, but then I will tell you it is 0 to 6, then 7 to 9, then 10 to 14. There is no continuity in this interval. 6, then again they have started with 7. You should not have a histogram with a break. 6 to 7, no, you have so many numbers between 6 to 7, 6.1, 6.2, 6.3, 6.11. So we have m numbers between 6 and 7. So this is not a histogram. When we consider option D, it's not a histogram because the intervals are not continuous. When I come to option B, here also there is a break in that class interval. 0 to 6, 9 to 11. It's not continuous and even their widths are not equal. All the intervals width size of that class interval should be equal. It means the width of the bar should be uniform. One is thin, one is fat. It is not accepted. Okay. See here then when I come to option C also, 6 to 7, 8 to 9. There is a break between 7 and 8. Again, this is not a histogram. When I come to this option A, 0 to 5, 5 to 10, 10 to 15, it is continuous. Okay. Just to confuse you, it is written 2 times. But here you will have 5. Then in this place you will have 10. Here this meeting point you will have 15. It keeps on going. Is it clear? And one more error in this is, if I count the data here, no, from 0 to 5 there is no prices. Below $5 we have nothing. So no bar is there. From 5 to 10, 1, 2, 3, 4, 5. We have 5 prices which is below 10. So I have 5 as the height of this bar, which represents the frequency of that price. Okay, then from 10 to 15, we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I have 7 datas. 3 14s and 4 15s. Together I have 7. It is correct. But when I come to 15 to 20, we have, after 15 I have to count. That 15 will go into that first bar. And 15.1 onwards it comes to the next bar. So I have 1, 2, 3 alone. I think while I cut and copy paste, I have missed a few datas. Okay children. So the best option is A. Even this option is also wrong. Among all these 4, best option is A. So I have given marks for the option A, which satisfies the basic necessity of a histogram. Is it clear children? Now the next thing that we are going to learn now is line graph. A line graph displays data that changes continuously over some factor. It can be a graph between time and distance, or it can be cost and quantity, or it can be over interest and amount. Okay. A graph displays a change, continuous change, not a break. We will not have any break. Continuous change. You would have come across many graphs like this. Even in everyday newspaper, you can see graph of COVID-19 deaths and new cases. There are many graphs representing a number of COVID-19 patients or new arrivals or deaths. Okay, children. And here are a few examples that I like to discuss with you. The given graph represents the total runs scored by 2 batsmen A and B during each of the 10 different matches in the year 2007. Study the graph and answer the following question. See here. Okay. Are you able to see this graph? How many line graphs are there here? Yes, we have 2 line graphs. We have a line graph with dotted lines and a line graph with continuous lines. Two line graphs are there. Imagine if I use two colors, no, it's of that type only. One in red color, one in blue color line. You can have it that way. The line graph with dotted line represents the data about batsman A. It is given on the top of this diagram. And the continuous line graph represents the data about batsman B. Okay, two batsmen A and B. And based on this data, we have to answer the following questions. What information is given on the two axes? The x-axis, it is about the number of matches or the matches they played. In first match, second match, third match, fourth match. Okay. In y-axis, it represents the score they got. Runs, how many runs they scored. In match 1, batsman A scored 20 runs. In the same match, batsman B scored 60 runs. Is it clear? But in second match, A scored highest run and B scored only 40 runs. That's how we will be reading this graph. Is it clear, children? Now the next question is, here they have just inclined the horizontal axis indicates the matches played during the year 2007, whereas the vertical axis shows the total runs scored in each match. The next thing is, which line shows the runs scored by batsman A? It is the dotted line. So the dotted line shows the runs scored by batsman A. Then where the runs scored by them same in any match? Have they scored same run in any match? In first match, both have scored different. In second match, here he scored 40 and he scored 120. Third match also, both are different. Fourth match, see here in fourth match, both of them scored 60 runs. So this is the intersecting point of both the line graph. Both the line graph intersect at match 4 and during that match, both of them scored same runs and it is 60 runs. Okay, children? Then the next question is, yes, it's where it's something different. Among the two batsmen, who is steadier? How do you judge it? Of course, you may not be asked how you judge it question during this exam because it is only MCQs. But you may get a question among the two batsmen, who is steadier? Who is steady? What is mean by steady? How will you justify one is steady and one is not steady? And if a student is scoring always above 90, he is steady. And there are students who scores always above 80, between 80 and 90, they are steady. But there are few students who sometimes get 90. On the other hand, in some exam they may get even 40. Will you say that student as a study student steady? No, he is not steady. Okay, likewise, with the help of this graph, tell me who is more steadier and who is more consistent player, whom I can believe more that he will surely give something to the team. See here, who is having more ups and more downs or not consistent. Their graph should be something closer to line. Not that much variation should be there. See, when I take batsman, he once scored 20, then he scored 110, 115. Again, sometime he even scored 0. 2 times he has scored 0. See here in the third match and ninth match, he scored 0. He is not steady at all. Whereas when I take batsman B, his average score is between 40 to 60 or 70. Only one time he scored a century, but then he never scored 0 anytime or never scored below 20. Somehow he makes up to above 40. So I can consider batsman B as a steady one. He is more consistent. I can have faith on him that he will give something to the team. But it is not that I will not believe batsman A. If he gives, it's a better luck. That's all. Okay. It all depends upon the field and pitch. Okay. Since A has lot of ups and downs, B is more consistent